Hey everyone, welcome back to the channel. As a kid I was always fascinated by the universe and how it worked. I would spend hours staring up at the stars, wondering what secrets they held. And as I got older I realized that some of the most mind-blowing mysteries weren't out there in space. They were right here at the smallest scales imaginable. That's the realm of quantum physics, a world where particles can be in two places at once, where information travels faster than light, and where reality itself seems to be in a constant state of flux. It's a field that challenges our everyday intuition and forces us to rethink everything we thought we knew about the universe. So, if you're ready to have your mind blown, join me as we explore 10 fascinating facts about quantum physics that will leave you questioning the very fabric of reality. Here are 10 fascinating facts about quantum physics. Okay, let's start with a real head-scratcher: quantum superposition. Imagine a tiny particle, like an electron. In the quantum world, this electron doesn't have to be in one place at a time. It's like it's playing a cosmic game of hide-and-seek, except it's hiding in multiple places simultaneously. Think of it like a spinning coin. Before it lands, it's both heads and tails at the same time. They exist in this fuzzy state of probability, called a superposition, until we try to measure them. And here's the kicker. The act of observing the particle forces it to choose a state. It's like the universe is saying, okay, you want to know where it is? Fine, but I'm only going to show you one possibility. This concept is so bizarre that even Einstein had trouble wrapping his head around it. Numerous experiments have confirmed that superposition is a real phenomenon. Hold on tight, because we're about to dive into one of the most mind-boggling phenomena in quantum physics: entanglement. Imagine two particles that are linked together in a way that even when they're separated by vast distances, they still act like they're connected. If you change the state of one particle, its entangled partner instantly changes its state too, no matter how far apart they are. This isn't just some theoretical idea. It's been experimentally verified time and time again. Scientists have even entangled particles and sent them to different continents, and the results are always the same: instant correlation. This spooky action at a distance, as Einstein called it, seems to violate one of the fundamental rules of physics. Nothing can travel faster than the speed of light. So how is it possible for these entangled particles to communicate with each other instantaneously across vast distances? Well, that's one of the biggest mysteries in quantum physics. Some physicists believe that entanglement might point to the existence of hidden dimensions or a deeper level of reality that we don't yet understand. Others think it could revolutionize communication and computing, leading to things like instantaneous data transfer and unhackable networks. The possibilities are truly mind-blowing, and we're only just beginning to scratch the surface of this strange and wonderful phenomenon. Get ready for a real brain twister, because we're about to talk about one of the most famous experiments in quantum physics, the double-slit experiment. This experiment has baffled physicists for decades and continues to spark debate about the nature of reality itself. Here's the gist. Imagine shining a beam of light at a barrier with two slits in it. Behind the barrier is a screen that records where the light hits. Now, common sense would tell you that the light would pass through the two slits and create two bright bands on the screen, right? Well, that's not what happens. Instead, the light creates an interference pattern, like waves overlapping each other. This suggests that light is behaving like a wave, spreading out and interfering with itself. But here's where it gets really weird. If you send individual particles of light, like photons, through the slits one at a time, you'd expect them to go through one slit or the other and create two distinct bands on the screen. But that's not what happens either. Even when sent one at a time, the photons still create an interference pattern, as if they were interfering with themselves. Chapter 4. The empty void that's not so empty: quantum fluctuations. We often think of a vacuum as completely empty space, nothingness. But in the quantum world, even a vacuum is teeming with activity. It's like a bubbling cauldron of energy and particles popping in and out of existence. These are called quantum fluctuations, and they're a direct consequence of the Heisenberg uncertainty principle, which states that you can never know both the position and momentum of a particle with perfect accuracy. So even in the emptiest regions of space, there's a minimum amount of energy that's always present, fluctuating and creating these virtual particles. These particles appear and disappear so quickly that we can't directly observe them, but their effects are real and measurable. For example, they're responsible for a phenomenon called the Casimir effect, where two metal plates placed very close together experience an attractive force due to the difference in quantum fluctuations between them. Chapter 5. Quantum computers, the future of computation. Get ready for a glimpse into the future of computing because we're about to talk about quantum computers, machines that harness the bizarre rules of quantum mechanics to perform calculations that are impossible for even the most powerful classical computers. Classical computers use bits, which can be either a 0 or a 1. Quantum computers, on the other hand, use qubits, which can be in a superposition of states, both 0 and 1 at the same time. This allows quantum computers to perform multiple calculations simultaneously, giving them an exponential speed advantage for certain types of problems. Imagine trying to find a specific grain of sand on a beach. A classical computer would have to search each grain one by one. A quantum computer, however, could analyze all the grains simultaneously, finding the right one much faster. This ability to perform parallel calculations makes quantum computers ideal for tackling complex problems in fields like medicine, materials, science, and artificial intelligence. They could be used to develop new drugs, design new materials with unprecedented properties, or create AI systems that are far more powerful than anything we have today. Chapter 6. Time travel, a quantum possibility? Fasten your seatbelts because we're about to venture into the realm of science fiction, or is it science fact? Time travel has always captivated the human imagination, and while it's long been considered the stuff of fantasy, some physicists believe that quantum mechanics might hold the key to unlocking this elusive dream. One of the most intriguing concepts is wormholes, theoretical tunnels that connect different points in spacetime. While the existence of wormholes has yet to be proven, Einstein's theory of general relativity suggests that they are possible. If we could create or manipulate these cosmic shortcuts, we might be able to travel vast distances across the universe or even journey through time. Another possibility lies in the realm of quantum tunneling, where particles can pass through energy barriers that classical physics would deem impassable. Some physicists speculate that if we could somehow scale up this phenomenon to the macroscopic level, we might be able to tunnel through time itself. While the possibility of time travel remains highly speculative, the fact that it's even being considered within the realm of theoretical physics is a testament to the mind-bending nature of quantum mechanics. Chapter 7. Schrödinger's Cat, a Paradox of Life and Death. Get ready to meet the most famous feline in physics, Schrödinger's cat. This thought experiment, devised by Erwin Schrödinger in 1935, is a classic illustration of the bizarre nature of quantum superposition and the challenges it poses to our everyday understanding of reality. Imagine a cat sealed inside a box with a device that has a 50% chance of releasing a lethal poison. According to quantum mechanics, until we open the box and observe the cat, it exists in a superposition of states, both alive and dead at the same time. Schrödinger's cat isn't meant to be a realistic scenario, it's a thought experiment designed to highlight the paradoxical nature of quantum superposition when applied to macroscopic objects. In the quantum world, particles can exist in multiple states at once, but in our everyday experience, cats are either alive or dead. They don't exist in some fuzzy in-between state. The thought experiment raises profound questions about the role of observation and measurement in quantum mechanics. Chapter 8. Walking Through Walls, the Magic of Quantum Tunneling. Imagine walking through walls. It sounds like something out of a science fiction movie, right? But in the quantum world, this seemingly impossible feat is a reality, thanks to a phenomenon called quantum tunneling. At the subatomic level, particles don't behave like tiny billiard balls bouncing around. Instead, they exhibit wave-like properties, meaning they have a probability of existing in certain locations. Now imagine a particle encountering a barrier, like a wall. In classical physics, if the particle doesn't have enough energy to overcome the barrier, it will simply bounce back. But in the quantum world, there's a small probability that the particle's wave function can extend through the barrier, allowing it to appear on the other side, as if it had tunneled through the wall. This phenomenon is not just a theoretical curiosity, it has real-world applications. For example, quantum tunneling is essential for the operation of transistors, the building blocks of modern electronics. It's also responsible for nuclear fusion in the sun, where protons can tunnel through the electrostatic repulsion barrier and fuse together, releasing enormous amounts of energy. Chapter 9. Light wave or particle? The answer: both. Light, it's all around us, illuminating our world and allowing us to see. But have you ever stopped to think about what light actually is? For centuries, scientists debated whether light was a wave or a stream of particles. Isaac Newton believed that light was made up of tiny particles called corpuscles, while Christian Huygens argued that light behaved like a wave. And for a while, both theories seemed to explain certain aspects of light's behavior. But then came along quantum mechanics, and it threw everyone for a loop. It turns out that light isn't just a wave or a particle, it's both. This mind-boggling concept is known as wave-particle duality. How can something be two completely different things at the same time? Well, that's the beauty and mystery of quantum mechanics. It tells us that the way we observe light determines how it behaves. Chapter 10. Is our universe a simulation? The quantum realm's biggest mystery. Hold on to your hats because we're about to explore one of the most mind-blowing and controversial ideas in modern physics, the simulation hypothesis. This theory proposes that our entire universe might be a giant quantum computer simulation created by a more advanced civilization. It sounds like something straight out of the Matrix, but hear me out. As we've seen throughout this video, quantum mechanics is full of bizarre and counterintuitive phenomena that challenge our very understanding of reality. From particles existing in multiple states at once to information seemingly traveling faster than the speed of light, the quantum world often feels more like science fiction than science fact. So what if these strange and wonderful properties of the quantum realm are not glitches in the Matrix, but rather clues to the true nature of our reality? What if the universe is not what it seems, but rather a highly sophisticated simulation running on some cosmic computer? While the simulation hypothesis remains highly speculative, it's a fascinating and thought-provoking idea that has captured the imagination of physicists, philosophers, and futurists alike. So, there you have it. 10 mind-blowing facts about quantum physics that reveal a universe stranger and more wonderful than we could have ever imagined. From particles behaving like waves to the possibility of time travel, quantum mechanics challenges our everyday intuition and forces us to rethink our place in the cosmos. But this is just the tip of the iceberg. The quantum realm is full of mysteries that continue to baffle and inspire physicists today. And as we continue to explore this strange and wonderful world, we can be sure to uncover even more mind-blowing discoveries that will revolutionize our understanding of the universe and our place in it. So, keep asking questions, keep exploring, and never stop being curious about the universe and all its wonders. Want more mind-blowing science facts? Like, share and subscribe for daily discoveries. Stay curious and keep exploring science.